Good morning, students. Yesterday we have discussed about distance time graph. Today we will discuss about velocity time graph. Similar to distance time graph, the time will be taken on x-axis and the velocity will be taken on y-axis. And we will also consider here if the object is moving in uniform motion, then first we will do how we calculate the slope. Yesterday we have also calculated the slope of distance time graph. Similar to that, we will calculate the slope of velocity time graph and see the result. What will be the result of the slope? And what is the slope of distance time graph gives us? It gives us the value of speed. And today we will discuss about the velocity time graph slope. And you know the slope can be calculated by considering any 2 points on the graph. We have considered 2 points A and C, and we have drawn perpendicular on both the axes as we have done yesterday. And here is the triangle ABC. ABC, and we have to calculate this slope, and slope can be calculated by calculating perpendicular upon base in this triangle, and perpendicular is AB and base is BC. And what is AB here? AB is change in velocity, like 40 minus 20. What is 40? 40 meter per second is velocity, 20 meter per second is again velocity. But what does AB represents here? AB represents change in velocity. As we have done yesterday in distance time graph, AB also represents the change in distance. And change in distance with respect to time, it is known as speed. And here change in velocity with respect to time, what does it represents? It will represent acceleration, because acceleration having formula change in velocity with respect to time. And from graph, what is final velocity? Here, what is final velocity? At point A, it is 40, and at point C, it is 20. Means finally the object is at 40, but initially it was at 20 meter per second. We will put the values of V, U and time. 40 minus 20 meter per second upon time is, with respect to A it is 4 and with respect to C it is 2. 4 minus 2 seconds. And after dividing you will get 20 meter per second square. It is the acceleration. Means acceleration is equal to 20 meter per second square. And what does we conclude from this? That slope of VT graph gives the value of acceleration. Means it's clear now that slope of VT graph will gives us acceleration and slope of distance time graph will gives us speed. Now let's understand the nature of velocity time graph, or you can also say that speed time graph, because V is the symbol which is denoted for both velocity and speed. And what is velocity? Speed with direction is known as velocity. The first case is, as we have done in distance time graph also, when object moves with uniform acceleration. Here we have used the word acceleration, but in case of distance time graph we have used when object moves with uniform speed. But because the slope of distance time graph gives us the value of speed, but the slope of VT time graph gives us the value of acceleration. That's why instead of speed we have used the word acceleration. The first case is when the object is moving with uniform acceleration, then it will be a straight line. And next, when the object moves with non-uniform acceleration, then it will be a curved line, as similar to distance time graph we have done yesterday. But the third case is different, when object moves with constant velocity or zero acceleration. Constant velocity or zero acceleration. Why I have written this? Because constant velocity means there is no change in acceleration, and acceleration is change in velocity with respect to time. That's why this graph shows that object moves with constant velocity or zero acceleration. This is not the graph which represent the object is at rest. But if instead of velocity, if distance s is written here, then it represents the object is at rest. But here it is velocity and time, means the object is moving with some velocity but the velocity is not changing. That's why this graph represents the object moves with zero acceleration. That's all for the nature of the VT graph. But one more feature for this VT graph is that we can also calculate the distance, or you can say that the magnitude of displacement from velocity time graph. Magnitude of displacement means we can't calculate the direction, but we can calculate the magnitude of displacement, and that is distance. You can also determine the distance moved by the object from velocity time graph. The area under the velocity time graphs gives you the distance moved by an object in given interval of time. Again, the graph is same if the object is moving with uniform acceleration. Here, because we know that velocity time graphs slope will gives us the value of acceleration, then this is the graph for uniformly accelerated motion. Again, the same, we consider 2 points and draw perpendicular on x-axis and complete all the lines. Then we will get this area which is under the curve. This area which is under the curve, that shaded portion, yani under this AB, this is the area ABDE, and this area represents the trapezium ABCDE. S can be calculated by calculating the area of ABCDE, and this ABCD is a trapezium, and trapezium having area of trapezium having formula half sum of parallel sides into height, and sum of parallel sides AE and BD, these two lines are parallel, so half AE into BD. And what is the height of trapezium? It is AC. ठीक है? Then, or you can also say that this area of triangle ABC plus area of rectangle ACDE, this will also gives you the same result, that is distance. It can also be calculated by calculating the area of triangle ABC plus area of rectangle AECD instead of using area of trapezium. Both are same. You can use any one if you want to calculate the distance from velocity time graph. And remember that from distance time graph, distance is given on the y-axis. That's why this is an extra feature which we can calculate only from VT graph. That distance can be calculating by calculating the area under the curve. And in case of non-uniformly accelerated motion, VT graph can have any shape. For example, this graph shows that velocity is decreasing with time, and this zigzag motion says that uniform variation of velocity, that velocity is varying non-uniformly. Sometimes it is increasing, then decreasing, again increasing, then decreasing. Because these shapes can also determine the motion of an object, and this is velocity time graph. So you can say velocity is increasing, or you can say velocity is decreasing in this part, again increasing, again decreasing. Now let's do the comparison between both the graphs. ST graph means distance time graph and VT graph means velocity time graph. How we will do the comparison? First case, when the object is moving with uniform speed, the graph will be a straight line, and when the object is moving with uniform acceleration, then VT graph is a straight line. When the object is moving with non-uniform speed, the graph is a curved line, and when object is moving with uniform acceleration, again it's a zigzag line, curved line, but it would not be a straight line. When the object is at rest, in case of distance time graph, the line which is parallel to time axis, it shows that the object is at rest. But in case of VT time graph, there is no case of an object when it is at rest, when the object is moving with a constant velocity or having zero acceleration. Then this graph shows the same. And slope of graph gives the value of speed, and slope of VT graph will gives the value of acceleration. But I have told you about that one more extra feature that is added in velocity time graph, that distance can be calculated by VT graph by calculating the area of trapezium or area under the curve. That's all for today. I hope you understood graphical representation of motion by both the graphs. Thank you.